Time we looked at an example problem. Can y'all pull that up in your notes? Like find it, if you can find it in the, we didn't graph the thing yet, right? Wasn't it like a concentration for a bloodstream or something of a drug?
Yeah, it's number 68 on page 707.
Yeah, so thank you. Page 707. Okay, so I think we got all the way to the point where we were ready to graph it. Does that sound right? Mm-hmm. Okay, so I wanted you to have graphed it, but let's go ahead and talk about what we need. Now, for this graph, I'm just going to graph the first quadrant because time has to stay positive. So this is time, right? So we'll say this is 1 hour, 2 hours, 3 hours. And then this is concentration. So I think we had maybe a max and min and maybe like an inflection point. I just brought the graph portion, I didn't bring the rest. So somebody that has notes, what points did we find? First of all, we definitely have an intercept here, right? And then at 1 hour, wasn't it like 0.1 and wasn't that the max?
Uh-huh.
Is that right?
Yes, relative max.
All right, so we're going to mark this 0.1. So at 1 second, we were up here. Okay. What else were we given? Did we have an inflection point?
No.
No inflection point at all?
Mm-hmm.
Okay. So honestly, that's the only point that we have, right? So when you go to pick additional points, we certainly need some, right? So I want you to be able to look at this graph and pick what you think appropriate additional points would be. Now, I would probably pick 2 and 3, but also it would be helpful to have something between 0 and 1, okay? So I'm going to pick the nicest fraction I can, but we do want a fraction between 0 and 1 just so we can see what it's doing to the left of the point that we know about, right? Okay, and what do we do with these? Plug them into where? The original, right? So you're going to get about 0.08 here, about 0.08 here, and about 0.06 here. So if this would be 0.05, right? Like halfway, if that's 0.1. So 0.8 is, this will be 1/2, is roughly here-ish. And then 2 would be level with that. And then 3 would be down a little bit. So just as we would kind of expect in a real-world setting, what does it look like is happening with the concentration of the drug? Well, for a while it's going up, right? It peaks at 1 hour and then it goes down after that, right? We are assuming it will eventually get down to what? 0, okay? Notice I didn't necessarily ask you to solve for that. Okay, so that's all for that. So we're going to kind of move on to something else, but I just want to kind of recap what I expect you to be able to do with the graphs. You need to be able to evaluate the original function, which tells you things like domain, intercepts, end behavior. You need to be able to evaluate the first derivative. What does the first derivative tell you about a graph?
It tells you that.
It does tell you that, but that's not. Yes, where the graph is increasing and decreasing, and also where any what? Extrema are. Extrema is the word we use for maxes and mins, right? And then what does second derivative tell us?
Concavity.
Yes, concavity, and what else? Inflection points. Okay, so all of those things you need to keep in mind. I mentioned this last week. I want to mention it again because we have a test coming up after spring break. I won't expect you to have memorized those steps. I will say, graph me this function by showing blah, blah, blah things. Okay, so you will have to know how to do all of those things. And when I say show me those things, I don't mean punch it in the calculator, find out where it's increasing and decreasing, and then just jot it down. That's not what I mean. Okay, so I know the $100 calculator can do it. That's why it costs $100. Okay, I want to know that you can do it using algebra and calculus. Okay, so keep that in mind. All right, so any questions before we move on to something else? This is so weird. Like, this class is already small enough, and now we're down to half. She didn't, but, well, maybe she did, but I haven't gotten it yet. Okay, so let's go ahead and look at the last new topic before test 2. It is a really important one that I will place a certain emphasis on the test. It is more problem-solved based in parts. In other words, word problems where they might not be cookie cutter type problems. So we've been discussing the relative or the local min and max, and today we're going to look at the absolute max and min. Because I don't know if you remember, but we can have multiple relative maxes, okay, of varying heights, okay, but the absolute maximum value, I think is pretty obvious, but it would be the overall max in an interval. So it's still often in an interval, it's not necessarily over the whole graph. And then of course we're going to have the absolute min. So while we can have multiple relative maxes and mins, we will only have one absolute max or min in an interval. There can only be one winner kind of thing. And one of the biggest things that we're going to talk about today is that an absolute max or min can only occur at a couple of locations. It either occurs at a turning point, and if you think about that, that seems obvious. This one maybe not as much, or an end point for the interval. And those are the only options. It's not going to be somewhere in between an end point and a turning point. The turning point will either be the max or the min, or where you started or stopped will be the max or the min. So let's go through some steps, and then we're going to look at some functions where we find the absolute maxes and mins, and then we're going to transition to some word problems where maybe we have to come up with the formulas ourselves. So how do you find the absolute extrema of f of x on a closed interval? Those are kind of sloppy, but those are brackets. So the first thing you need to do is you need to find the turning points. Those are often going to be the critical values. Do y'all remember how we find critical values or what they are? They are any time the first derivative is equal to what? 0? Number 2, once you find all the critical values, you're going to compute f of c. Notice that's not f prime, that's f, the original function, for each critical value. C on the interval from A to B from step 1. Make sure C lies in the interval from A to B. And if not, you're going to ignore it. So we only want values that are valid for our interval. And then you're going to want to find the y's. Yep, sorry. Okay, so how will you find the y's? Yes. Find the y's, and you also need to find f of A and f of B. Those will be the y values at the endpoints. Okay, and then the largest one is going to be the absolute max. And the absolute min is going to be the smallest. So all you're doing is kind of reducing it down to some options for possible absolute maxes and mins, and then in the end you're just going to find all of them and find the biggest and the smallest one. So if I ask you to find the absolute extrema, what's absolute extrema going to be in general? Yeah, the max and the min both, right? So find the absolute extrema for x cubed plus 3x squared minus 1 on the interval from -3 to 2. In other words, I only want to look at that graph from x equals -3 to x equals 2. So the first thing I need to do is find critical values, because that is one option for my absolute max and min. Okay, so let's find the first derivative. What would that be? 3x squared plus 6x, and we're going to set that equal to 0. Okay, what can we factor out of both? 3x. So if we do that, we're left with x plus 2. So we end up getting two critical values, but you need to carefully make sure that those critical values are in the window that we're being asked about. Okay, are these in the window we're being asked about? Is 0 in between those two numbers we were given? Yes. Is -2 in between those values we were given? Yes. Okay. So these are critical values in our interval, so we are good to check them basically. Okay, so what the theory says is that the only place that we could find an absolute max or min are either these two locations or possibly what else? Possibly the endpoints, right? Those are the only four options in this case. Okay, we have two critical values to test, and we have two endpoints. Okay, so over off to the side, let's find the y's. So we need to find f of 0. We need to find f of -2. But then we also need to find f of both endpoints. This is always your strategy. Pull out your c values that are in your interval. Test your endpoints also. Alright, so f of 0 is just going to be -1. F of -2, you can use your calculator, is going to be 3. This one's going to be -1. And then this one's going to be 19.
And we plug this back into the
Original, that's what, yeah. It says f instead of f prime. So these are the y values for the critical points, while these are the y values for the what? Endpoints. Okay, and our theory says the absolute max or min have to be at one of those locations. Okay, and then you just pick which is the biggest and the smallest. Okay, so which one is the biggest? That's the biggest, right? So that's going to be the max. Okay, notice that we have a tie for the smallest, right? We have a tie for these two. What that means is we have kind of a double min. So the absolute mins in this case are 0, -1, and -3, -1. Why did I pick those for mins? Because they are literally the smallest ones I got, right? I just look at the y values, okay? What was the largest y I got? 219. Okay. So I kind of have a tie for the absolute min, in other words. So I'm going to write down here, we need to choose the smallest y, or y's in this case, and the largest y. That's what we did there. Okay, so let's do Maybe another one where perhaps we're not given an interval necessarily. If we're not given an interval, it's assumed that it's over the whole graph. So find the absolute extrema for f of x equals 2x squared plus 3x minus 4 on the interval from negative infinity to infinity. You might see the question tell you that, hey, we're going to include the whole domain, or it might not say anything. If it doesn't list an interval, then we're just assuming it's over the whole graph. So it's probably helpful if we know what kind of graph this is, and we should from algebra, right? What kind of graph will this be? A parabola facing which direction? Upward, because that 2 is positive, which means we're going to have a min, but no what? No max. Okay, so let's go ahead and find the critical value. So the critical value is going to be whatever makes the first derivative 0. Okay, so what is the first derivative? 4x plus 3. So we have x equals negative 3/4. Okay, so notice this is a critical value. Do we need to worry about making sure it's in the interval? No, because we don't have an interval, right? Also notice that means that we have no endpoints. So in other words, how many y values do we really need to find on this one? Only one, right? And it's going to have to be the what? It's going to have to be the min. Okay, there's really no options. So we're going to find f of negative 3/4 to find the y. Okay, I didn't write this out for the earlier ones, but you would just stick it in the original, right? So 2 times this value squared plus 3 times this value minus 4. Use your calculator, and you'll get negative 41/8. Now, if you were trying to graph that, I would probably change that to a decimal, but for now, we're not really trying to do that. So the absolute minimum would be negative 3/4, comma, negative 41/8. And there would be no absolute max. So there will not always be both, particularly when you're not given an interval. When you're given an interval, you can always find a high and a low point.
So if that function had been a negative 2x squared plus 3x, it would have been an upside down problem, there would have been no advantage.
Correct. Okay, so let's look at another one maybe with an interval. I wanted to show you one of each, and then, so find the absolute extrema for the following. So g of x equals 1/2 x to the 4th minus 2/3 x cubed minus 2x squared plus 3 on the interval from 0 to 3. Make sure you have your calculator out, because I'm going to have y'all punch these in this time instead of me give you what the y values are. So y'all tell me, what should we do first?
We're going to take the derivative first.
First, we got to take the derivative. That is correct. So even though there are fractions, the derivative will actually be nice. It's kind of set up that way. Okay, what happens when we move the 4 to the front? What's 1/2 of 4? 2, right? So we get 2x cubed minus, what happens when we move that 3 out to the front? It cancels, and we get what? 2x squared minus 4x. Remember, the derivative of a constant is always 0. And we're going to set that equal to 0. So, pull out anything they have in common, because they do have some stuff, right? What do they have in common? 2x. And then we'll get x squared minus x minus 2. Right, but let's finish factoring it first. Yeah, so what are the factors of negative 2 that add up to negative 1? Minus 2 and plus 1. What if it doesn't factor? You have to use your old favorite friend, what? Quadratic formula, yes. Okay. So I know we don't love that, but that's what you have to do when it doesn't factor. So we get x equals 0 and x equals 2. And x equals negative 1? Okay? So do you see an issue with any of our critical values? You need to verify that they are in our interval, right? So what do you notice about one of them?
-1.
Yeah, -1 is no good, right? So -1 is going to be completely ignored, okay? It is not in the interval. But notice these are, okay? So these are our critical values. By the way, -1 is still a critical value. It's just not a critical value in the interval we're looking for. And so is unimportant to us for a problem like this. Okay, so now what?
So now we have to do G of 0, G of 2, G of 0, G of 3, but we don't have to do 0.
Right, so we know that the absolute extrema have to lie either here or at the endpoint, right? Notice that one of our critical values happens to be one of our endpoints, so we don't have to test it twice. So we're going to find G of 0, we're going to find G of 2, and we're going to find G of 3. So I want you to do that real quick. I want you to punch that in and see what you get, and then I want you to pick out the biggest and the smallest one. Oh, hey, Marisol, I didn't see you come in. And it was dark, so I didn't see you at first. Jaylee came in. All right, so G of 0, I mean, you shouldn't have to plug that in your calculator, right? A bunch of stuff's going to go away, leaving what only? 3. Okay. What'd y'all get for a G of 2? -7/3. My suggestion when you're trying to find max or min, maybe change that to a decimal, right? That would be -2.3. Okay. Just so that you can make sure and compare. What about G of 3? I got 15/2 or 7.5. Okay, so which one's obviously the largest? Yeah, this is your max, right? And which one's your smallest? This one, right? Okay, now when you list what they are, I don't want you to list the decimals. So for the absolute min, I would want you to say 2, -7/3, because that's more exact. And then for the max, you could use a decimal if you want. So in other words, I don't want you to round. I don't want you to round if you don't have to. So for the max, you could have said 7.5 because that still would have been fully accurate, but I wouldn't want you to say -2.3 for the min because it's actually -2.333 forever. Okay, just remember kind of while you're finishing up that you can certainly check these on your calculator, the graphing portion. I know we use the calculator portion to plug in the values, but let's go to y and enter in that equation. So it's 1/2 x to the 4th minus 2/3 x cubed minus 2x squared plus 3. So what you would want to do is look at the graph, but remember to only look at the graph between what values? 0 and 3. So you got to give it a minute.
I keep getting an error. Why every time it gets done it says error?
On your graph, are you possibly using the minus sign instead of the negative sign for something?
Like it graphs it and then it waits for a second and then it says error.
What does the error say? Like a domain problem?
And then it stops error, syntax, quit, go to.
say go to. Go to will always try to tell you, hey,
Oh, that's
you did something weird, yeah. So it was graphing your original one, then it was going down to your Y8 and thinking, what the heck is she doing here? Yeah. All right, so let's kind of look at these from 0 to 3, right? If you kind of sectioned off this graph, notice the min would be right where we said it was, right? 2 and then down to about negative 2.3. And then the max, notice, is at the end point. So that's a little harder to see. So look where like my pen's pointing. It'd be like here-ish, okay? So it's harder to see when it's at the end point, okay? But if you sectioned off the graph, if you just took this piece to here, 0 to 3, then you can see what your max and min should have been, okay? Okay, so let's look at some word problems, some application where maybe we aren't given an interval to look at, but we'll have to think about what's reasonable for the problem that we're working on. So if you have a book, we're going to look at number 44 on page 720. I'm going to give you the gist of it, so you don't have to open up your book if you don't have one with you, but I like to refer to the book with word problems so that we don't have to write the whole thing out, okay, because I'm lazy and I don't want to, okay. So here we're talking about the height of a rocket, and here is the equation listed for the height of the rocket. So we have negative 1/3 t cubed plus 4t squared plus 20t plus 2, where h of t represents height in feet. Yeah, I had to make sure it was in feet. And t is obviously time, but you need to be more specific. If you read through this problem, it's seconds into the flight. Okay, so before we answer the actual question, okay, how far off the ground is the rocket when we shoot it? You should be able to tell me that. 2 feet. How'd you get that?
Because that is your,
Because the height at time 0, which means you haven't done what yet?
that's your line.
You haven't fired the rocket yet. The height is 2 feet, right? And so we are supposed to be finding the maximum altitude. What's altitude another name for? Altitude's another name for height. Okay, they're asking how high up the rocket's going to go. Okay, so how are we going to find that? The maximum or the minimum has to occur at one of 2 places, right? At either a what? Critical value or a what? Endpoint, okay? So first let's find the critical values, and then we'll talk about how the endpoints, at least one of them, is kind of implied. What's the derivative? Negative t squared plus 8t plus 20. And we want to set that equal to 0. It would probably be a lot easier to factor if it weren't for what? The negative, right? So we always try to make our life easier, so let's just factor out a negative. So that'll be t squared minus 8t minus 20. I'm allowed to do that as long as I factor it out of everything, okay? And then notice we ignore the negative 1 for now. We just need to try to factor it. So what are the factors of negative 20 that add up to negative 8? 10 and 2, which one needs to be positive, which one needs to be negative? Yeah, so it's t minus 10 and t plus 2. Okay, so we end up getting 2 critical values, 10 and negative 2.
Okay, so like, this is probably a dumb question, but I always forget, like, you know, we take out that negative 1.
Mm-hmm. You can factor it without it. You'll still get the same
So, like-
answers. But you're going to get really weird.
So nothing
Signs.
ever happens to the 1 though? Like, we don't.
Well, negative 1 can't be 0, right? So when you factor out a constant, you don't have to worry about any number you pull out, negative 1 or otherwise. Because negative 1, you could try to set it equal to 0, but it won't be 0, right? So yeah, we don't have to worry about that. All right, which one is out because it doesn't make sense for the problem?
Can't have negative time.
Can't have negative time. So this one's invalid. Okay, which means that we only have 1 critical value in the interval. By the way, what's the interval assumed to be?
Or, well, I guess infinity. 0?
It'd be like 0 to infinity, right? Even though they didn't tell us that, right? Time could technically keep counting, although eventually what's going to happen to the rocket? It's going to hit the ground, right? We just don't necessarily know when it's going to do that, okay? So technically speaking, which values do we need to check then? We definitely need to check 10, but which one are we technically also supposed to check? 0, okay? So we're going to check h of 10. We're also going to check h of 2, but h of 0, which is 2. But unless you had a really poor design for your rocket, we're going to assume that which one's not going to be the max. The 0 one's not going to be the max, but just for good measure, we're going to go ahead and check it, okay? So if you plug in 10, so somebody go ahead and do that for me. Notice we're finding y's, so we always use which equation when we're trying to find y's? The original, right? So let's just do like an approximate, because I don't think it comes out nicely.
I got 269.
So let's do to 1 decimal place, so 268.7 feet. Okay, so that means this is the max, right? So I'm just going to mark this. This is the absolute max. So even though logic dictates that it probably won't be this one, notice we mentioned it anyway, because technically speaking, it could be an endpoint or a critical value, okay? On the right side of the interval, we didn't check that, right? We can't, right? We can't plug in infinity, we can't check that. Okay, so let's look at another one where maybe the numbers aren't so pleasant. So let's look at number 68 on page 722. I'm going to look over this one myself because to make sure I've got the right wording of it. I wrote down the equation, but it's been a minute since I looked at this one. Okay, so this is the average price of homes in Massachusetts over a certain time period. Okay, and so the price equation is this right here, negative 0.183 t squared plus 4.65 t, or sorry, that's t cubed. Can't read my own writing. And then this one squared, minus 17.3 t plus 200. Making sure I got all of it. It does mention that time needs to stay between what two values? 0 and 12. Okay, so before we get started, let's make sure we know what each thing stands for. Okay, this is the price of the home in thousands if you read the problem. And T is, of course, time again, but you need to be more specific. In this problem, it's years after 1990, which means we're only going to what year? Remember, this is an old book. I let y'all buy an old book so you could save money, which means our dates are going to be really old, right? So 1990 to 2002, yeah. So it's a little old, but that's all right. All right, so, and the problem asks you to find the minimum price. Okay, so how do we find maxes or mins? Set the derivative equal to 0, so we're not going to love the derivative on this one, okay? So you're going to want to probably use your calculator, but you're going to need to multiply that decimal times 3, okay? So I got negative 0.549 t squared plus 9.3 t minus 17.3, and I want to set that equal to 0. So I think it's pretty clear that no matter what we do, we can't factor this. So what do we do instead again? Use quadratic formula. So I want you to take like 2 minutes and see if you can figure out what that is. See if you can get the same thing I am going to get. So first let's lay out what our A, B, and C are. A is negative 0.549, right? B is 9.3. C is negative 17.3. When I'm teaching quadratic formula to high school students, to junior high students, I always make them write out what the A, B, and C are so that they don't make sign errors or whatever, and then go ahead and plug it in. By the way, it's not x equals in this problem, it's t equals and then the quadratic formula. So 2 minutes and see what you can get there. Does anybody else have homework for today? I just got Kristen's, the one that was due today, the 2 problems. All right, I think y'all are at the point where you're punching it in. So let's see if, I'm going to write out what I would have,
Oh, I was supposed to say, that's the answer? No, that's
no,
not.
no, no. I'm going to write out what I would have punched in my calculator.
Get that. I totally messed up with stuff wrong. Or I totally messed up.
You know, the key here is you want to use parentheses, right? Like you want to close off the parentheses in the denominator, under the square root, all that stuff. So I think it's something you can fix if you don't get the answers that you're supposed to, but I think it was definitely approximate. I got, I think, 2.13
Yeah.
and 14.81.
Oh, I got them right. We're from, what? Oh, I didn't put this in.
Another way to do it in the calculator is to use the, well, on mine it says stow at the bottom. It lets you put the number and then you put the alphabet next to it.
Oh.
You just plug in the letters.
Yeah. So she just like in her memory stored A, B, and C and then
Yeah.
entered in the letters. You can do that too. Okay, so which one doesn't make sense for the interval we're looking at? This is a fine time, right? But it's not in our interval, right? So this is invalid. This is not in the interval from 0 to 12. Okay, so how many critical values do we have to test then?
3.
Well, one critical value to test, but we also, y'all are answering my overall question. How many values overall do we need to test though? 3. So now we need to find the y's. Okay, and we're going to do that by doing P of 2.13 but also P of 0 and P of 12. I'm going to do the easy one. P of 0 is 200. Make sure you remember that it's 1,000 though. So the price of the house was 200,000 in year what, by the way? What year are we starting at?
1990.
1990. Okay. These are both going to be, I think, approximate. So notice these are the endpoints. We have to make sure we check all of them. All right, so because we're talking about money, I think we can just move the decimal place 3 times when we're talking about thousands. Squared minus 17.3 times 12 plus 200. So I got about, actually I got exactly, so I'm going to change this right here. I'm going to write it as we would normally see a house price. 200,000 for this one. This one comes out to be exactly 345,776. Now the 2.13 is definitely going to be rounded. How come? The 2.13 has already been rounded, right? So we can definitely expect that to be an approximate answer. I did that one last because it was kind of a pain in the butt. So I got about 182,479. Technically, you could have said in 15 cents if you wanted to, but since, you know, I don't think we rarely see house prices on the market for cents, right? So I think we can just round to the nearest dollar there, okay? So which one, what are we looking for, by the way? The min, right? So here's the min, right? So if you were to write like a short little sentence, what would you say?
The lowest.
So what year are we talking about? It's 2.13, so that's somewhere in the year what? 1992, okay? So in 1992, the house prices were the lowest. At around 182,479. Okay. Technically, it's 0.13 into year 92, right? So you could do 0.13 times 12 and decide that that would be technically in February. Okay, about halfway through February would be when that would be. Okay. Okay. So I want you to, there's not very many of you, okay? So I'm glad I didn't type this up now that I see how many of you there are. Marisol, do you have a book with you? You do, I see you have it. Okay, I want you to do a problem, and you're also going to use your phones and the internet to see if this is legit. Since we have an old book, we can actually see if what we find came to be or not, okay? So I want you to, for an in-class activity grade today, I want you to look at number 70. So this is,
On 7.2?
yes ma'am. And so I want you to do number 70. On page 722. Now this is talking about the world's population, okay? And it's asking you to find when it says show that the world population is forecast to peak around 2071, okay? So that means you already know the answer, what to expect, right? And then I want you to see if you can answer part B also, okay? So, maybe no more than 10 minutes or so. If y'all want to pair up, you can, although there's not very many of y'all.
This on a separate paper, like, are you turning it in?
No, but I am gonna come by and look at it. So like Marisol, at the end of class, you can just send me a picture of it. Kayla, whenever you watch this, you can just send me a picture of it. So never mind about the whole internet thing, but I thought you might be able to find internet sources saying when the world population would peak, but
When I wrote down the T this time, I decades.
the United Nations estimate that it's around 2045. So obviously we've like amped up our baby making.
Yeah, everybody and their mom's pregnant.
That's so true. I think you just notice that more when like you don't want to be pregnant and you're like, holy crap, what's going
No,
on?
I
here?"
noticed it because
Oh, well, that too. Just wait till you graduate.
I am crazy.
Wait till you graduate.
I'm waiting until I get a ring first, obviously.
Well, that would be good too.
It's coming. Yeah, it'll be here before we know it. Because graduation's already coming pretty fast. Oh, my.
So Kayla, you can pause this and fast forward through it so you're not just like sitting for 10 minutes on radio silence, right?
But
How
you,
do you, getting the cube up there?
this is what you're not having.
Huge, there's no huge.
Okay. But like, when you do this, does it end up? Oh, yeah, I think so. Because it was 61616. Is it the same page?
666.
216? Okay, now this is 616.
I find you a double problem.
Yeah. Yeah, but like, I think you have to, when you do this, then you want to do something else.
You have to do that in parentheses.
Yeah. I really don't know, just math, because I gotta, you know.
So it's another quadratic formula one, right?
It sure
Wah,
is.
wah.
Okay, so I got
did the same thing. I was like, idiot. Oh, heck. Yes, good job.
We're so supportive of each other. We all need friends like that.
Now we have to plug these in.
But first you made it, show the road.
Kristen's like, we're done.
Wish.
So we go over here. P, what's the little dude? So the 56 is here.
Bless you. Bless you. That was a dainty sneeze and then a regular sneeze.
So it's, this 56 is 0, right? Between 0 and 10.
Yeah.
And then, so we have to
So-
do 0 and 10 also, right? Oh God, back into that one now, that's so rude. Bless you.
So disrespectful.
Okay, this is not. Okay, that is something else. Oh my gosh. I just started.
It's weird that it's not like Yes. And then you said
So the peak would be the max, right?
Yeah.
So then it's the 9.
Well,
Yeah.
Yeah.
So.
What year did you start?
7, 1, 2, 0, 8.
So it was like 2007. In decades. So that's 70 years?
But if it's like 7.1, it'd be 71 years. See what I mean?
Yeah.
Okay.
Yeah. Yeah.
I mean, kind of, and like our smile is like straight.
Well, because even their best patterns, like, can't.
They have it reaching in 2050 even higher than what our number is in 2050.
Right, yeah. That's why I said I looked it up and the UN shows that it's like 2050 something.
Yeah.
So, I guess the scarier part is what's going to cause the population decline at whatever year. You know what I mean? Like, natural disaster, lack of food, what? Okay, so notice this one. What did y'all end up getting for T?
T, 7.12.
7.12, okay. So that means since it's in decades that it's like 71.2 years, okay? By the way, 0.2 doesn't mean it's in February, right? You'd have to do 0.2 times 12 to figure out what month it is, okay? It actually would still be February because it'd be 2.4, but it'd be like mid-February. And then how do you figure out what the population will peak at?
Put that together.
Yeah, it would be best if you didn't round that answer also. So it'd be best if you put like as much of, even if you use like the answer key where it stores the whole thing, okay, to plug it back in, that would be helpful. Okay, so about what did you get the population to peak at?
7.08.
7.08 what?
9.08, I'm sorry.
9.08 billion people, right? So, so yeah. So my intention with that was to have y'all look it up. Okay, Jeffrey looked it up. I already kind of mentioned that. Obviously, their predictions were a little off, right? So because this book is kind of old information, but frankly, that's going to happen, right? The predictions are just that. They're just predictions. So, okay.
Perfect.
Nope, definitely not. So I think I'm going to stop here. Normally, I go ahead to the next section. This section is called optimization. Okay, so before we move on, I didn't really mention what the title of the section was.
Yeah, you did.
When you optimize something, what does that mean?
You're the
You make it like the most efficient, right? So for some things, that would mean finding the maximum, right? But for other things, that would mean finding the minimum, right? So if you think like in the business world, you would want to maximize your revenue, right? But you'd want to minimize your costs, right? So optimization doesn't always mean finding the highest. It can mean finding the lowest, okay? In the example of if you're trying to buy a house, you don't want the maximum house price, right? You would want the minimum house price. So on Wednesday, we're going to look at more complicated scenarios where maybe we aren't given an equation ahead of time and we have to determine what the formula is ourselves and then try to optimize that, okay? But in general, by the way, the title of that section is creatively called Optimization 2. Okay, so all we're really doing is applying the max admin stuff to like real life settings. Okay, all right. So I'm going to give you a homework assignment. This isn't going to be due till after spring break. Okay, so my suggestion to you, you're going to have 2 assignments due the same day because I'm not going to make, I'm not going to give you a week and extra time on Wednesday's assignment. So Monday and Wednesday's assignment are both going to be due the day you come back. Okay. Also, we're taking a test the Wednesday after spring break. So I want to give you the